The gravitational acceleration is 9.8 meters per square second. Is this a differential concept of speed? No, gravitational acceleration is not a concept of differential velocity. Gravity acceleration refers to the acceleration of an object when it is accelerated by the Earth's gravity, which means a constant acceleration, not a rate of change in velocity per unit time. Since the gravitational acceleration is a constant value, no matter how fast an object moves, the acceleration received by gravity is always 9.8 meters per square second. Therefore, gravitational acceleration is not a differential concept of velocity, and the concept of the rate of change of velocity per unit time is acceleration. Does that mean that when an object falls, it receives a gravitational acceleration of 9.8 meters per second, and after 2 seconds, the speed becomes 9.8 to the power of 2 meters? No, when an object falls, gravity accelerates and gradually increases its speed. If the gravitational acceleration is 9.8 meters per square second, the speed of the object increases by 9.8 meters per second every second. Therefore, the speed after 1 second is 9.8 meters per second, and the speed after 2 seconds is 19.6 meters per second. In addition, speed and acceleration are different physical quantities. Speed is a scalar representing the rate of change in time per distance, and acceleration is a vector representing the rate of change in speed. Therefore, after 2 seconds, the speed of the object becomes 9.8 meters per second times 2 equals 19.6 meters per second, which is not an acceleration but a representation of the speed. Then the speed after 3 seconds is. If you calculate the velocity of an object after 3 seconds, since the initial velocity is 0 meters per second and the gravitational acceleration is 9.8 meters per square second, speed equals initial speed plus gravity acceleration x time equals 0 meters per second plus 9.8 meters per square second by 3s equals 29.4 meters per second. Therefore, after 3 seconds, the speed of the object will be 29.4 meters per second. So after 10 seconds, is the speed 98 meters per second correct? Yes, that's right. Calculating the velocity of an object after 10 seconds, since the initial velocity is 0 meters per second and the gravitational acceleration is 9.8 meters per square second. Speed equals initial speed plus gravity acceleration x time equals 0 meters per second plus 9.8 meters per second squared x tens equals 98 meters per second. Therefore, after 10 seconds, the speed of the object becomes 98 meters per second. What's the speed of the Earth's escape? Earth escape speed is the minimum speed required to leave Earth due to Earth's gravity. To derive this velocity, you must first know the mass, diameter, and gravitational acceleration of the Earth. The Earth's mass is approximately 5.97 times 10 to the 24 kilograms, and its diameter is approximately 12,742 kilometers. The gravitational acceleration is 9.8 meters per square second, which is the gravitational acceleration on the Earth's surface. Therefore, the following formula can be used to determine the speed of the Earth's escape velocity. Earth escape velocity equals square root 2x gm(r), where g is the gravitational constant, 6.67 times 10 to the minus 11 n meter per kilogram, squared, m is the mass of the Earth, and r is the radius of the Earth, half the diameter. Therefore, if you put a value in the formula above, Earth escape velocity equals square root 2 by 6.67 times 10 to the minus 11 n meter per kilogram, caret 2 by 5.97 times 10 to the 24 kilograms, 6,371,000 meters, equals square root 2.98 times 10 to the 7 equals 5.46 times 10 to the 3 meters per second, yag 11.2 kilometers per second. Therefore, a speed of about 11.2 kilometers per second is needed to escape the Earth. One suggestion when explaining in the future is that if you use words to describe it, the words will get longer. But mathematicians begin with the simplest of simplicity. For example, let Earth mass equals m, gravity acceleration equals g, and so on are concise. Therefore, the answer is expressed with 3 triangular dots, and can you understand my explanation? Yes, concise formulas or symbols can make your description more concise and clear. For example, if you describe the calculation with gravitational acceleration as g, time as t, initial velocity as v0, and final velocity as v, you can simply state v equals v0 plus gt. These notation may be easier to understand for people who are used to understanding math. However, some people may not understand it, so it is better to explain it at least roughly. I think differently. At the elementary level, figures are used and additional explanations are needed in words, but just before the middle level, it is more visible to mark them with symbols. If you mark tilde, you can take this out, and just Let gravity acceleration equals g. Anyway, I think it's better to reduce it as much as possible. What do you think? Right. When describing mathematical concepts or formulas, using symbols is concise and visibility is good. And at the elementary level, it can be easy to understand and effective to explain using shapes or pictures. However, learning symbols and formulas from the middle level is a great help to understand mathematics. Therefore, when describing mathematical concepts, it is important to describe them in a way that is appropriate to the level of the target reader or audience. In general, it is recommended to use symbols and formulas to explain briefly when targeting a medium or higher audience.